Hello everyone, welcome to Abhyas IIT Prep channel. I am Dr. Karthikeya. In this video, we are going to discuss kinetic theory of gases 2024 JEE mains questions related to January phase, and in another video, we are going to discuss kinetic theory of gases April phase questions related to 2024 year. So as usual, in the beginning we are discussing what are the prerequisites that are required to solve the questions. So you need to understand the concepts behind the things, kinetic theory of gases, how to solve the different questions. In order to solve the questions, you need to know what is degrees of freedom. As usual, thermodynamics basics that are related to previous chapter. So those are like different kinds of process and ideal gas equations you should know. So mainly in the previous chapter, that is thermodynamics, you should know what is different kinds of process. But in this, especially in this chapter, you need to know different different speeds or velocities of gas molecules, and what is specific heat, CPCV. That also you should know. How to calculate the mixture of gases. There will be some problems related to that. How to calculate CPCV for the mixture, and also degrees of freedom for the mixture of gases. Like that, this kind of problems you should know. This kind of theoretical part you should know before trying to solve the questions. As usual, coming to this first January shift. So in the first question, we have monoatomic gas and diatomic gas. So molar specific heat for constant volume of mixture you should know. So this is a standard question. Okay. Here, what is a mixture? If you see N1CV1 plus N2CV2 by N1 plus N2. Okay. Here, CV you can write for the monoatomic gas, that is what? 3 by 2 RT plus into 2 plus this one 6 into 5 by 2 RT by 2 plus 6. Okay. Cancel. 3. 15 plus 3, 18. 18 RT. 18 RT by 8. Okay. 9. This is 4. 9 by 4 is how much? 2.5. Okay. Okay, 9 by 4, you just divide. 4 to 8, 1 is remaining point. 2.2, again 10, right? 2.2. Then 2 will be there, 2.25 R. Okay, because the options are very close, you have to calculate like this. This is the answer, simple question, right? So another thing is related to root means speed, that is RMS velocity. Root means square. Velocity RMS, VRMS equal to root of 3RT by M. This is the formula. So, but what he wants? Hydrogen molecule is, okay, is a 2 km per second. Oxygen you need to calculate. So, VRMS is inversely proportional because remaining things are same at the same condition. He told at the same conditions. R is gas constant, temperature is that. So, is inversely proportional to the molecular weight. VH2 by VO2 is equal to root of MO2 by MH2. MO2 is 32 by MH2 is 2. So, okay, that is 16. Okay, VH2 is how much? 2 km per second. 2 km by VO2 is equal to 4. Okay, then what happened? VO2 is equal to 0.5 km per second. Okay, this is the answer. Next question. Next question also related to kinetic energy. Kinetic energy, here they have given in the form of kb. You know, kinetic energy is equal to 3 by 2 kbt. Okay, but this is energy. What you need to calculate? Temperature you need to calculate. So here 0.414 electron volts means 1.6 into 10 power minus 19 into 2 by 3 into kb value how much? 1.38 into 10 power of minus 23 is equal to temperature. If you calculate this, the temperature will be around 3200 Kelvin. Okay, this is the answer. Simple calculations, just try to do this. So it will be like this. Okay, now going to the next question. Total kinetic energy. Here in the previous question, it was given kb. But now, what is this? Moles is given, that is N, R is given. So another formula for this one, kinetic energy equal to N. Okay, kinetic energy for this. What is the type of gas? Oxygen, diatomic. NF by 2 RT. Okay. So diatomic means 5 by 2. N is 1 mole. R is 8.31. Okay. Temperature is 27 plus 270, that is 300 Kelvin. So if you calculate this, it will be around 6232, I think. 6232.5 joules. Okay. Just direct formulas. If you apply in that formula, directly you will get the answer. Okay. Going to the next question. Here, we need to calculate in this question pressure of A to the pressure of B. But what they have given? They have given two vessels of same size means volume same. Same temperature means temperature same. One is mass of the A is given, mass of the B is given. So, you know from the ideal gas equation, PV equal to nRT. PV equal to nRT. PA VA is equal to NA RTA divided by PB VB. Okay. By NB RTB. Okay. TA TB cancel, same temperature, volume, same size cancel. PA by PB is equal to, this is Na means, okay, moles, 1 by 2 by 1 by 32. Okay, then 16 is the answer. So direct question, simple question. Pressure is directly proportional to number of moles. Moles is equal to mass by molecular weight. Okay, directly I have written. So this is the answer. Next, temperature of gas is there. Okay, temperature of the gas having, this is N by V is given, pressure is given, Kb is given. So cannot PV equal to nRT, but this is what? PV is equal to N number of molecules by Avogadro number RT. Okay, this is P N by V, R by N A is KT. Okay, this is 2.0 into 10 power 25 into K is what? 1.38 into 10 power minus 23 into temperature. This is 1.38 atmospheric pressure, 1 into 10 power of 5 pascals. You just try to calculate. Temperature will be around 500 Kelvin. Yeah, temperature will be 500 Kelvin. You just check it, calculate this, so you will get the 500 Kelvin. Just direct formula only, PV equal to nRT, but R by Na is K. This you need to calculate. N by V already given, that's why I changed this question in this format. Okay. Now going to the next question, simple questions, right? Only direct formulas, just keeping the values, you are getting the answer. Okay. Now what you need to calculate? Again, monoatomic gas is mixed with diatomic gas. Okay. Initially, adiabatic exponent you need to calculate. Gamma is equal to 1 plus 2 by F. This you know. So that's why we need to calculate degrees of freedom. That is F is equal to N1 F1 plus N2 F2 by N1 plus N2. Okay, because moles is given. Okay, here 3 moles of monoatomic gas. 3 into how much? Monoatomic gas degrees of freedom is 3. Okay, plus N2 2 moles. N2 is 2 moles. That is given 2 into, this is 5 by, next N1 is 3 plus 2. 9 plus 5, 9 plus 10, 19 by 5. Okay, next gamma is equal to 1 plus 2 into 5 by 19. So F, if you substitute in this, you will get this 1 plus 10 by 19, that is 29 by 19. Okay, So yes, calculate 19 ones 19, 1 point. Then what happened? Okay. So, okay, just calculate 19, 10. 10 will be there. Point means 100. 19 5 is a 95. Okay, next 50 will be there. 19 2 is a 38. 1.52. Okay, this is the answer. Okay, simple calculation. So directly you got there. Next question is related to, here graph is given two thermodynamic process A and B. Okay, you know that from the graph, if you calculate the slope, then what happened? Log P is equal to gamma into log V. Taking this one, then what happened? P equal to V power gamma. Remove the log. Just try to do this. This will come to this one. Log V power gamma. Remove the log. You will get this. P V power minus gamma equal to constant. So, you know, is equal to Cp is equal to C plus R by this one. You will get 1 plus gamma. Okay. This is the first one. That is Ca. So another thing also, if you for the B, if you take, then what happened? Log P is equal to 1. Tan 45 is 1 slope log V. So then what happened? P is equal to V power 1. If you bring this side, P power constant. So then what happened? Constant. This is specificate for the Cb. This is Ca. This is Cb is equal to C plus R by 1 plus 2. But you know, general formula, that is Cp is equal to Cv plus R by 1 plus gamma, that is 2. Okay. This is 1 plus 1, that is 2. Okay. R by 1 plus gamma. Okay. If you see here, Cp is equal to Cv by R plus 1 gamma. Okay. This one. So then what happened? Cp is greater than Cb is how much? This is 1 plus 1, 2. Okay, this is, so denominator, how much if it is less, that much value will be more. So if you see here, Cp is greater than Cb, greater than Ca, okay, greater than gamma, because gamma value greater than 1. So if you compare Ca and Cb, what happens? Cb is C plus R by 2. This is Cb equal to R by 1 plus gamma. Gamma value already more than that. Okay, this is A, right? This is B, this is A. So that means Cb value more than Ca. Cp is there. Okay, this is Cp equal to Cv plus R by 1 plus gamma. So that means Cp is more than Cv and it is more. Okay, so that's why Cp equal to Cb greater than this one. This is the extra option that is given. Actually in the NTA website we have 4 options. No option is correct. But this is the extra option added in many materials. Okay, this is the answer. Okay, now going to the next question. Next question, what is the things? At which RMS velocity, both the, at which temperature RMS velocity of hydrogen equal to RMS velocity of oxygen. So you know that RMS velocity, Vrms equal to root of 3RT by m. But for the hydrogen, if you calculate, that is 3R temperature. At which temperature? That is the question. By molecular weight of hydrogen is 2. Similarly, 3 into R into temperature is 273 plus 47 degrees. What happened? 280 plus 4, that is 320. By molecular weight is 32. Root get cancelled. 3 get cancelled after removing the root. So 6, this one, what happened? Root cancelled. Okay, I'll just erase this. Okay, I'll just erase. Then what happened? Root get cancelled. T is equal to T by 2, you'll write 320 by this one, 10. So then what happened? T is equal to 20 Kelvin. Okay, directly you got. Simple question. Only if you know the RMS velocity, you will get the answer. So next question, if 3 molecules of monoatomic gas is mixed with 2 moles of diatomic gas, value of adiabatic exponent. Already we have done this one. What happened? Gamma is equal to 1 plus 2 by F So F you need to calculate. F is equal to N1 F1 plus N2 F2 by N1 plus N2. Okay, 3 is into monoatomic gas 3. This is degrees of freedom. For the 2 molecules into degrees of freedom for the diatomic gas is 5 by N1 plus N2, that is 3 plus 2. So then what happened? 9 plus 19 by 5. Okay, gamma is equal to 1 plus 2 into 5 by 19, that is 29 by 19, that is 1.52. Okay, 2 times this type of model bit came. So okay, same type of question only in the 2 things. Okay, next one, parameter that remains constant. This is theoretical bit for all the molecules of gas at a given temperature is kinetic energy. Okay, kinetic energy, that is K E is equal to 3 by 2 kBT. Okay, this is the answer. Okay, remaining things vary. Okay, this is directly theoretical bit. That's why I'm not focusing. You need to understand theory before trying to solve the questions. Okay, next question. Next question, a gas mixture of consists of 8 moles of argon, 6 moles of, neglecting all vibrations, total internal energy. Internal energy, you know that NCV delta T. Okay, general thing. U is equal to NCV delta T. Okay, total internal energy of the system. Okay, so next, okay, in terms of RT is there, so that's why CV we need to change that one. So 8 moles, CV is 3R by 2 T plus, so combinationally U is equal to N1 CV1 plus N2 CV2 by N1 plus N2. Okay, here that is CV. Okay, after that you can do this. 6 into diatomic gas 5R by 2 into T by N1 plus N2. Okay, 8 plus 6. Okay, you just calculate this. That is CV. Okay, then okay, after that, like this also you can do. You just multiply with this one. 4 3 is 12 RT plus 3 5s 15 RT. Okay, this is the answer. N CV, that is directly you got mixture, CV mixture. So okay, into delta T, that is 27 RT. 27 RT. This is the answer. Okay. Yeah. These are the questions that are related to kinetic energy, January phase. Okay. I hope you enjoyed the session. So these are simple questions with just keeping the values in the formula. In this video, we are going to discuss kinetic theory of gases, JEE mains 2024 questions related to April phase, April shift. In order to solve these questions, we need to understand the basic concepts like what is RMS velocity, what are the different speeds that are possible for the gas molecules when they are traveling, and you need to understand how to convert the CPCV in terms of an internal energy related to that number of molecules and RT, like that. And you need to know the expression for RMS velocity, that is root 3 RT by m in terms of molecular weight. So these basics should be known. Okay, and other things like what is energy of a molecule in terms of Boltzmann constant, and also related to universal gas constant, how it is related. Okay, these expressions, how they came, if you know, you can easily solve all types of questions. Okay, yeah, welcome. Now we are systematically solve the questions according to different concepts that are there that came in the 2024. Yeah, first question, if you see the degrees of freedom for the translation and the CH4 molecule, if you try to observe the translation degrees of freedom for this, because it's CH4 molecule. So for the translation degrees of freedom and rotational degrees of freedom for this molecule is, what are the things? 3, 3. Okay, that is the TDF translation or DOF, degrees of freedom. Okay, in rotation side you have 3 degrees of freedom, and in the translation side also 3 degrees of freedom will be there. This is theoretical bit. Okay, directly you can solve. Okay, next one, you know that our collision frequency of hydrogen molecule in a closed chamber is Z. Collision frequency of the same system at 127 degrees centigrade. You know that if the mean free path for this one is, if it is constant, then F is proportional to V, proportional to root T. So if you consider F1 at a temperature T1, F2 at a temperature T2, that is 127 degrees centigrade. If you try to convert 27 plus 273, that is 300 by 400. So if you take this one as Z, so then what happen? 3 by root 2. Okay, sorry, root 3 by 2. Okay, root 3 by 2. Okay, so then what happen? F2 is equal to 2 by, so okay, if you bring this side to this side, 2 by root 3 into Z. This is the answer. So degrees of freedom is directly proportional to root of temperature T. So then you will get a 2 by root 3. This is the answer. Okay, simple questions, right? Only thing, if you know the how to solve the question using different formula. Application means if you know, then you will get every answer. During adiabatic process, pressure is proportional to temperature. Pressure is proportional to temperature. So in that PV equal to nRT, that is another one. So these two are constant for a fixed gas. So you need to calculate Cp by Cv. So then what happen? You just try to do this. Pt power minus 3 is equal to constant. Okay, just substitute this temperature. PV is proportional to temperature. You just substitute in this, because we need to get the Cp by Cv for the adiabatic process. You know that is PV power gamma equal to constant. In terms of this expression we are trying to do, that is the power minus 3 is equal to constant. So P power 1, P power minus 3, you will get to P power minus 2, V power minus 3. So if you try to arrange in terms of this one, PV power 3 by 2 you will get, because you bring this side 1 by P square V cube equal to constant. So then P square V cube equal to constant you will get. That is, so after that if you rearrange the terms, then what happened? PV power 3 by 2. So if you see this expression, what happened? Gamma equal to 3 by 2. Okay, this is the answer. Okay, simple questions. Okay, hardly 1 or 2 steps you are getting the 4 marks. Next, direct bit 1 by, this is what? Okay, distance covered by a molecule between two successive collisions, that is mean free path 1 by root 2 n pi by pi d square. This is the answer. So direct, without any calculation, if you know the expression, you get the 4 marks. That much simple this is. Okay, next question. Yes, sample contains a mixture of this one. So what you need to calculate? Root mean square of the helium and oxygen in the sample. Okay, you know that ratio you need to calculate. Ratio VRMS is equal to root 3 RT by M. Okay, VH helium by V oxygen, okay, is equal to molecular weight of root of molecular weight of oxygen by molecular weight of helium. Okay, so then what happened? This is 32 by 4, that is what? 8. What you need to calculate? Helium with respect to oxygen, that is 2 root 2 by 1. So okay, this one 2 root 2 by 1. This is the answer. Okay, simple questions. Okay, reciprocal you will get oxygen 32, helium 4. This is the answer. Okay, now going to the next question. You know that you need to calculate the expression, that is specific heat. You need to calculate. Okay, so given real gas equation. So you know that for a ideal gas equation, PV equal to nRT. Okay, so if you do differentiation, PdV equal to nR dt for the ideal gas equation, this is the thing. And you know, also know from the first law of thermodynamics, dq equal to du plus pdv work. Okay, this is ncp dt. Okay, and that only you need to calculate. Okay, ncp dt is equal to ncv dt plus this is r dt, general expression. But here the expression is pv square equal to rt. For that you need to do pv square equal to rt. P into 2v dv is equal to r dt. Okay, r dt. So then what happened? pv dv equal to, okay, r dt. Okay. So then p dv, if you want to know, r dt by v. Okay, r dt by 2v, sorry, 2v. So you just replace that. So for this real gas equation, nc dt is equal to ncv dt plus this is also there, n, okay, n r dt by 2v, all n's, sorry, yeah, all, I will erase this. Okay, I will write again. nr dt. Okay, dt cancelled on all the sides, n also cancelled, then c is equal to cv plus r by 2v. Where is the expression? R by 2v. This is the answer. Okay, cp is equal to cv plus r by 2v. For this gas, generally cp equal to cv plus r. Okay, for the ideal gas equation. So, but here real gas expression is pv square equal to rt. For that, this is the answer. Okay, just use the ideal gas equation and try to differentiate, you will get the answer. Okay, next question. Energy of a 10 non-rigid diatomic molecules. Initially, you need to calculate this degrees of freedom. Okay. Okay. Another thing, for that if you calculate, you will get this, for this expression non-rigid diatomic molecule. So degrees of freedom will be this one. So then energy of one molecule is 3 by 2 kb dt or nf by 2 rt. Okay, degrees of freedom is 7. Okay, so number of molecule is, if you are considering one diatomic molecule, okay, 7 by 2 rt. Okay, but here if you multiply with 10, you will get what? 5. That is 35 rt. Okay, number of molecules if you consider 1. So degrees of freedom will be f if you calculate this. So directly if you substitute for one molecule, n into f by 2 into rt. But for 10 molecules, energy for one molecule is this one. Energy for 10 molecules, if you try to calculate, you will get, you have to multiply with 10. Then 35 rt you will get. This is the answer. So you just initially need to calculate degrees of freedom for this rigid molecule, you will get the f equal to 7. Okay. Next question. Next question, what you need to calculate? Ratio specified at constant volumes you need to calculate. Here mixture is there, monoatomic gas and diatomic gas, 1 mole only. You need that, you know that. Okay. Constant volume for monoatomic gases, NCV dt, right? Generally, okay. But Cv is equal to, for the monoatomic gas 3R by 2, for the diatomic gas it is 5R by 2. How to? Constant volume ratio you need to calculate, that is Cv1 if you consider for this Cv2. Cv1 by Cv2 is 3 by 5. This is direct question. Just if you know this expression, directly you will get the answer. It's very, very simple question. Okay. Now going to the next question. These are theoretical bits. You know that just now we discussed mean free path of the gas molecules is inversely proportional to square of the molecules. Just now in this video only we just discussed d square nap. Okay, so this is rt by, okay, this is mean free path, okay, if you consider. So from this you can see mean free path is inversely proportional to d square, right? This one is right. Similarly, average kinetic energy of gas is directly proportional to absolute temperature. You know that NF by 2 RT, that is KE. So KE is proportional to temperature. That is also right. So from this, if you know these expressions, you know if you remember the expressions, you just directly solve this question. Very, very easiest one. So both statements are right. Okay. This is the answer. Statement 1 is true. Statement true also. 2 also true. So both statements are true. Okay, next one. Next one, if you see, what you need to calculate, temperature is given, average translation kinetic energy is given, that is K. Temperature at which average translation kinetic energy will be 2K. So you know that KE is proportional to temperature. First one is K, that is minus 78. That means 273 minus 78 is 195 Kelvin. So first one 195. Second one, if you consider, that is 2K. Temperature should also be double. That means 195 into 2. 195 into 2, how much? That is, okay, 390. 390 Kelvin. You need to convert into degrees centigrade. That is 390 minus 273. So what you will get? That is 117 degrees centigrade. This is the answer. First one is, so if you know this kinetic energy expression, you just directly get the answer. That is 117 degrees centigrade. Okay, these are very, very simple questions based on the expressions that are there. So hardly 1 or 2 minutes were trying to solve each and every question. That means all are easiest problems mostly. I hope you enjoyed this session. Thank you once again. All the best. So please subscribe the channel. Thank you.